We are doing right triangle trig day 2, and we are going to be investigating the unit circle. So when we measure the degrees, the angles around a circle, we use the unit degree, as I said, correct?
Yes.
Well, from here on out, there's another measure of angles that sometimes makes it easier to work with, and that measure is called a radian. Okay? So we need to find out what a radian means. So a radian is an angle measure. Radian, so like that. It's an angle measure created by arc lengths that are equal to your radius. Okay? So a radian is an angle measure created by arc lengths that are equal to your radius. And it doesn't matter what size circle you have, when you set your arc length equal to your radius, that angle that it creates will be the same for every circle. Alright, and what you're going to do today is create the radians around your circle that you have in front of you. So everyone should have a piece of string that is the length of the radius. 8 centimeters. There's no radius string there. Okay? Alright, so verify that your string is the length of the radius. Give or take a little error, yes? And now what I want you to do is, so you should double check that your string measures the length of your radius. And then, starting here, quietly, we're calling this is where 0 degrees is, right? Well, that's also 0 radians. Alright, so I want you to take your string and start it here and move it, not move it, but lay it on the arc of the circle until it stops. Okay, so you're going to lay your string right along the circle. You're going to curve it. Okay, so you don't have to, so here it is. You're going to take this little bit, no, you're going to move it from the center. And you're going to start it here and lay it on the circle. So it's going to overlay the circle from here to maybe about here. All right, take your string, lay it from here until the end of the string on the circle, just to get your head out. Do not turn the other. Do not. You walk with your head with So, here. So, starting at 0. We want 0 up on the right. We want 0 this way. And you want to lay this on here. Stretch it. Lay it right there. Okay. All right. So, when you get to the end of that, that's 1 radius. So if I draw in the angle from here to there, nope, you don't have to do that. But I do want you to put this mark on the circle, and I want you to label that 1 radius. Then I want you to keep going all the way around the circle. I want to see how many radians it takes to get around the circle. Okay, let's find out. You draw this little one. Then you move your string to here, and you lay it here to get the next one. And I don't need the different colors yet. 1 color is fine now.
What if you don't have any?
I'll prepare you the colors later. Woo!
I like to hear.
Ian loves colors.
Sorry, you gonna write that big force anywhere?
All right.
When did you save yourself?
So take that string. How many times does it take for it to get around the circle? How many together? On the circle. Yes, yes. Got it on the circle.
Oh my gosh.
How many times?
Oh, that's beautiful.
I know. 6 and a little bit, right? So we should have seen 6 and a little bit times to get around the entire circle.
Yeah.
Do we agree?
Yeah.
Okay. So it takes 6 point something radians to get around the entire circle, for a full circle. Okay? All right, so we all should have seen that. And the actual value that it takes for radians to get around the circle is 6.28. Ah, well, what is pi? 3.14, and it takes us 6.28 to get around the circle. What? So, 360 degrees is equal to 2 pi radians. And that equivalency is what we will use to rename some angles in radians around the circle. So this is a definition. 360 degrees equals 2 pi radians. So what would 1 pi radian equal? 180 degrees equals pi radians. Okay. Set your string aside, set your circle aside. The important thing to have on that page is that 360 degrees equals 2 pi radians, and 180 degrees equals pi radians. Okay.
Are we done with that page?
That page we are done.
Wow. Whoa.
Oh.
So 6.28 now.
All right. The next thing we need is,
What color would you recommend for this next one?
I will talk colors when the time comes. Okay.
Oh.
All right. So the next page should be the front side of the two circles that are partitioned. They are the same on both sides. Because we're going to do one side with radians and one side with degrees. Okay? All right. So when we deal with the unit circle, we deal with some special angles that we can, that we've actually already investigated in geometry. So, because they are easy for us to figure out, we will not need a calculator when the time comes. But let's first start labeling degrees. So on this side, I want you to label it degrees at the top. Top right, call this degrees. You want the ones with fewer partitions to be on the upper left.
Why didn't you come up before? You can't get it the other way.
Okay. The one with fewer partitions to be in the upper left. Quiet, please. Yes. Stop talking. All right, here we go. So we're going to label the important degrees. Now, if I take my circle and I put the coordinate axes through here, quiet please, and then I take each of those quadrants and cut them in half, what's the measure of this angle right here? 45 degrees. So we're going to start with 0 degrees here. And we're going to have 45 degrees here. What's this one going to be? 90 degrees. 45 degrees more would put us at what? Careful. One what? 35. 135, then 180. Stop it. Next one. 225. Put it in the white. Okay, and then, yep, I heard it. 270. Next, 315. Okay, so those are all our positive angles. Notice, positive angles are going counterclockwise. So negative angles would go clockwise. And standard form for an angle is started at 0 degrees. So I needed to do 45 degrees. I would start at 0, and I would go 45 in the counterclockwise. So at 90 degrees, I'd start at 0 and go clockwise up to there for 90 degrees. Okay? Now, if I wanted negative angles, then I would be going clockwise. So negative 45 would put me here. So this angle can be called positive 315 to end there, or negative 45 degrees. Yep, we're going to do that all the way around. So the next one would be negative what? Negative 90. Negative, wrong way.
135.
Negative 135. Negative 180. Negative 225. I promise you that these note sheets will be very helpful when it comes to homework time. Okay, so then this one would be what? Negative 270. And this one, negative 315. And then negative 360. So this is 0 and 360. It is also 0 and negative 360. Okay? All right. So 45-degree angles are special angles that we will work with on the unit circle. The other special angles are 30 and 60 degrees. So this one, this circle that we have down here, is broken up into 30-degree increments. All right, so we have this one, we still have 0 here. This one would be what? 30 degrees, then 60 degrees, and I'll keep going. 90 degrees, 120, 150, 180, 210, 240, 270, 300, and 330. And again, yep, we can go around the other direction, so we can call this 0 and 360. Okay, I'm not going to label those again. I'll label maybe one of them. We can call this angle what? Negative 30 degrees. Okay, just so we're clear. We're going clockwise, they are the negative angles. All right, any questions on labeling angles and degrees? Okay, am I okay to change page?
Yes.
Look over to that. I still want to go on with the fewer partitions in the upper left corner.
Oh, I need to go back and
This one is labeled radius. All right, are we ready to switch? We're going on.
Let's go.
All right, so this side will be labeled radius. So it's just another way to label angles. You have not seen before. You now know how we made radians. Okay, we made them ourselves. But we need to make some conversions for those special angles. So we need to convert 45 degrees, 30 degrees, and 60 degrees, and 90 degrees. Let's do those to radians. All right, and the way we do that is 45 degrees multiplied by pi radians, it's like a unit conversion, per 180 degrees. Because there are pi radians in 180 degrees. And 45 divided by 180, we don't want decimal, it comes out very nicely, and we want to leave it in terms of pi. That will be pi over 4. So we want to label it that way. So if I simplify 45 over 180, because pi is a very nice number to work with when we deal with these, because taking a cosine and sine of pi becomes very important. Yes?
So I think 45 divided by 180 or 180 divided by
45 goes into 180 4 times. 45 goes into 45 once, it goes into 180 4 times. Because 45 goes into 90 twice. It comes out nice and even, yeah.
So is that pi over 4 just like the radians form of 45 degrees?
Exactly. So pi over 4 radians is equal to 45 degrees. Okay? All right, now let's do 30 degrees. 30 degrees times pi over 180. So 30 over 180 reduces to 1 over what? 6. So pi 6 radians is equal to 30 degrees.
Wow.
Okay, we keep going. 60 degrees. Nope, that's like 60 over 180 reduces to what? 1 over 3. Did I hear that?
Yeah.
So this is pi thirds. And we'll do one more for 90. There's your pi over 2. So 90 degrees times pi over 180 is equal to pi over 2. All right, so now we're going to label these circles the same way. These are the exact same angles, just labeled differently. Now labeled with radians. So we'll do the 45-degree one first. So we no longer call this 45, we call it what? Pi over 4. Now everybody listen to me, this is really important. You can ask your question first.
It's still 0 degrees.
This is still 0 radians, yes. 0 degrees, 0 radians. All right. So when we start labeling the unit circle, the easiest way to get the angles correct in radians is to think that I'm counting, I'm doing pi fourths, I'm counting by pi fourths all the way around. So this is 1 pi fourth. If I go 45 degrees more, that is 2 pi fourths. And 2 pi fourths is equal to what? Look at this, no, let's look. 2 pi over 4 is the same as pi over 2, which we showed down here, 90 degrees and pi halves, right? Okay, so that's 1 pi fourth, 2 pi fourths. Simplify them when you can. What's the next one? No, keep counting. 1, 2, this one is 3 pi fourths, which can't be reduced. That's why it's nice to count this way, to figure out that that is 3 pi fourths. Okay, we go 45 degrees more, and that is 4 pi fourths, which is pi.
Oh.
All right. Pi fourths one more time is 4 pi. This is pi.
What is pi?
Yeah, I should.
5 pi fourths.
So 4 pi fourths. What's in the 4 over? Pi. The fours cancel out. So sorry, I was just fixing the screen. So 4 pi fourths, the fours cancel out, and that is equal to pi. The next one is what? 5 pi fourths. Quiet, please. Quiet. 5 pi fourths does not reduce. So that stays 5 pi fourths. Then this one ends up being what? 6 pi fourths, which reduces to what? 3 pi halves. And then here is what? 7 pi fourths. All right. One more would be 8 pi fourths. And 8 pi fourths reduces to?
2.
Thank you. 2 pi. So this is 0 and 2 pi.
Are we going to have to do the negative one?
Yep.
Oh.
Yep. All right. So do we understand and do we have these labels correctly? Talking about. All right. So here we have 1 pi fourth, 2 pi fourth, 3 pi fourth, 4 pi fourth, 5, 6, 7, and 8 pi fourth. So label these around here. Now we want to label the one with 30-degree angles and 60-degree angles.
Okay.
The easy way to do this is to start with the smaller of the two. Pi 6 is equal to 30 degrees, right?
Yeah.
So this one is 0. This is pi 6. 1 pi 6. So if I keep adding 30 degrees all the way around, I'll hit all my 60s as well, correct?
Yeah.
All right, so we're going to count on pi 6. This is 1 pi 6. The next one will be 2 pi 6, which reduces to pi over 3. There you go. The next one will be 3 pi 6, which reduces to pi half. Yeah. And that's at 90 degrees. That makes sense. So that was 3 pi 6. The next one is Careful.
4 pi 4.
4 pi 6, which reduces to
2 pi 3.
2 pi thirds. And you can just have the simplified one on this one. All right, so that's 4 pi 6. The next one is 5 pi 6. With a pi. Yeah. The next one is 6 pi 6, which is a pi.
So is that always pi?
Yes. Yep. Yep. And next one will be what? 7 pi 6. Next one?
4 pi over 3.
Very nice. 4 pi over 3. That's 8 pi 6. 9 pi 6.
3 pi.
Same as it was on the other one, right? 3 pi over 2.
2.
10 pi 6 reduces to?
5 pi over 3.
Yes, 5 pi over 3. And then 11 pi 6. Okay. So, part of your homework tonight is to simply draw angles, either positive angles or negative angles, with radians or degrees. Use this note sheet to help you remember how to draw those angles. Okay? All right. So let me give one example though so you can see it. I'll put it down here. Quiet, please. Quiet. I talked to you about talking in between. All right. So let's say I ask you to draw the angle -7 pi fourths. Okay? So we have our coordinate axes. Pi fourths are the 45, correct? So negative pi fourths would be here, and you just keep counting until you get to -7 pi fourths. So negative pi fourths would be here. That's 1, 2 pi fourths, 3, 4, 5, 6, 7. So the angle ends here, and we will be going around like that. -7 pi over 4. Good. I asked that you try. All right. Now let's move on. Okay. Next you want to pull out your sheet, your left sheet. And have all those legs. Here's the color. Here's the color.
Color me up.
We're going to want 3 colors. I'm coming to you, don't come up here. Pencil can be 1 color and then 2 others. You guys should. I want all of my color pens back. Pencil can be 1.
Oh, yeah.
All of these color pens come back in here. Okay, so now we are going to be labeling this unit circle with all those angles that you just came up with. And we will also be labeling it with C, sines, and cosines so that we can answer all of these questions. So, before we start, we need to remind ourselves about 3 special triangles. And you can do this on the back of this sheet. So, the first is 30, 60, 90. It's going to look like that. The second one, on the back of the paper you're doing this, we will get there, but next one will be 60 here, 30 here, and 90 there. And the third one is that 45, 41, 90. Okay. All right. So we're going to be laying these triangles onto this unit circle. And when we do this, the hypotenuse is always going to be what length? For the unit circle? It's 1. So label the hypotenuse in each of these 1. All right, so special triangles, that's from geometry. If it is a 30, 60, 90 triangle, the side opposite of 30 is always half of the hypotenuse. So this is 1, this side is 1/2. And then if we use Pythagorean theorem to find the other side, we find out that this one is √3 times half, or √3/2. Okay?
Wait, how do we find that again?
That would be Pythagorean theorem, 1 squared minus 1/2 squared. You can take it forward. Okay? All right, slide please. So this is the same triangle just flipped around. So this side is 1/2, and this side is √3/2. Okay, those are easy enough. Now, with a 45, 45, 90, the two legs are the same length. And basically we're doing a squared plus a squared equals 1. Right, because these two are the same length. So that's 2a squared equals 1. We divide by 2. We get a squared equals 1/2, and we take the square root. A equals the square root of 1/2. Now, the way that that's usually written on the unit circle is √2/2. So this side is √2/2, and this side is √2/2. Okay? If you recall yesterday when we did the unit circle, we said that the sine was the y of the angle, the cosine of the angle was the x, and the tangent was the y over x. Oh, okay. All right. So the first thing we want to do is start labeling our angles and our radians. So the way that yours is set up is you have a blank comma blank degree. So we want to start putting in all of those degrees that we just figured out on the other pages. So this was 0. We'll put radians first. So in the blank over on the right, you'll have 0, 0 degrees.
What color is this?
You can do this quietly. Let's do all of these in your first color. Okay? Yeah. No, it's a 2. √2. These two are the same. √2/2. Okay. So, we have 0 radians. The first number is going to be radians. The second will be degrees. So if this was 45 degrees, so here you'll have pi/4, 45. I'm just getting all of these labeled all the way around. Oh, sorry, that one's 30, not 45. I'm sorry. You're sure it's 30. I'm sure it's 30. I know it is. So this one is 30 degrees. So pi/6 slightly and 30 degrees.
100% positive.
Yes.
Before I write it.
Yes. The next one is the pi/4 and 45 degrees. And on this one, we have pi/3 and 60 degrees. And the one at the top was what? 90 degrees. And so first is pi/2, 90 degrees. Now we're at 120. What did we label that with? That's 2 pi/3 and 120 degrees. This middle one is 3 pi/4 and 135 degrees. This one was 5 pi/6 and 150 degrees. And what's this? Pi and 180 degrees. We keep going, it goes up by 30 to 15, 15. So this is 210 and, we have 7 pi 6. So the first number is 7 pi 6 and 210 degrees. This is 5 pi 4th and 225 degrees. Then we have 4 pi 3rd, 240 degrees. The bottom one was 3 pi half and 270 degrees. Then we have 5 pi 3rd and 300 degrees. 7 pi 4th and 315 degrees. And 11 pi 6 and 330 degrees. Okay, stay put. Now, so, your homework for the weekend will be just the drawing of the angle, and we will finish the unit circle when we get back together. The worksheet. Andre at the door. So, I need all my colored pens back in the yellow container, and you can have a worksheet on your way out the door. Everything here? Go over here. What's up? My pen's going in the yellow cup over there. Alright? Keep rubbing. Oh, try. Try to find it. All my pens back, please. Set up. Unfortunate. One weekend. Sorry, so, you need to compare it to your pictures that you have. Seven pi 6 from 0. 7 pi 6 is 6 pi 6, 7 pi 6. 7 pi 6. You draw your draw there. Okay. Yeah.
So I don't know a lot of stuff. I missed like
Okay. So you're going to need to make it up while you're going. Come and see me outside the house and we can check in everything else. Okay. But don't just avoid things because you get done. Got it? Yeah, kind of strange.